Ladies and gentlemen, welcome to help video number 144, which will begin with question 12 on today or on the test, Unit 1 test 1-13, and we start on question 12, and this is dealing with symbols that are commonly found in chemical equations. The very first symbol here, what is the symbol that we would use for a substance that must be dissolved in water in order for the chemical reaction to occur? Well, you would not put parentheses D water after it. D stands for density of water. The symbol that we use for the fact that something must be dissolved in water for the reaction to take place is parentheses AQ. So if we have, for instance, two salts that we want to react, well, salts are not good at reacting when they're in solid form. So if we have two solid salts and we pour them together and mix, the chances of them reacting are not very high at all. So what is an easy way to get them to react? Well, in order to get the salts to react, we've got to pull the salts apart so that the ions in that salt are free to react. A great thing that serves to pull the ions apart in the salt so that the ions from one salt can react with the ions from the other salt is water. So if you see an AQ written after anything in a chemical equation, it means you have to put that substance, that salt, in water, dissolve the salt in water so that the ions from one salt can react with the others. It is an AQ. AQ stands for the word aqueous. Aqueous, aqua, water. Number 13. One of the following sets contains only chemical properties. For this question, I've highlighted the ones in green as chemical. The ones in orange are physical. So we're looking for chemical properties. Chemical properties are those properties that relate to how a substance behaves around another substance. In other words, how does that substance react with other substances? Well, the ability to transmit light does not involve other chemicals. Whether it's soluble in alcohol, you're like, does that involve other chemicals? Alcohol is another chemical. Well, solubility is not a chemical reaction. Solubility is, does that alcohol, which is a liquid, have the ability to pull the substance apart? The substance is still there, it's just dissolved. So solubility refers to dissolving something. And in this case, they'd be talking about alcohol. That's not a chemical. That would be physical because it's not chemically reacting. The alcohol is just pulling it apart. It's still in there, though. Melting a point, whether the temperature at something melts, is physical because when it melts, it's just going from a solid to a liquid. It's the same substance there, though. That's a change. Melting involves measuring the temperature at which a substance changed a state of matter. State of matter changes are physical. Oh my gosh, letter B. How corrosive is the substance? Corrosive refers to, does that substance cause other substances to rust and break down? Flammability is how well the substance burns. After something's burned, that's a chemical change or a chemical reaction. Does the substance react with acids? That's a chemical change because once it's reacted with the acids, we've made new substances. So chemical properties refer to how it behaves chemically. How does it change chemically into other substances? And those three are all chemical changes. Letter C is all physical. How it conducts heat or electricity is physical because you can conduct heat and electricity without yourself changing. How hard a substance is a physical property. The boiling point of substance is the temperature at which it rapidly goes from liquid state to gas state. The substance hasn't changed, it's just changed its state. Color of something is a physical property. Malleability is how well it can be pounded thin and bent into shapes. Ductility is how well it can be rolled into wire or stretched. Those are all physical properties of a substance. Question 14 is referring to what we're seeing here in this chemical equation. Here we have magnesium, which is a solid. It is a metal. We're adding heat energy to it. It's reacting with oxygen as we added heat energy. In other words, stuck it in a burner flame. And when we are finished, we had magnesium oxide, which is a salt. Folks, we actually saw this one happen in our chemical versus physical changes lab. They took a piece of magnesium wire, or magnesium strip. They cut it in a piece, or they bent it into shapes, and they stuck it in a burner flame, and we saw that bright flash of light. And that bright flash of light happened as it reacted with oxygen in the presence of a burner flame. So which of the statements is true about this? Are the products magnesium and oxygen? No, magnesium and oxygen are not the products. Those are the reactants. The product is what we made, magnesium oxide. It was that whitish powdery salt that we saw formed after the silvery ribbon was in the burner flame. From the equation above, letter B, from the equation above, it was evidence that heat must be added. Yep, there's heat written above the energy, delta heat plus delta heat. That triangle means you have to change the heat. The plus means we have to add it. From this equation, it means to get this reaction to occur, we do have to add heat. That is a true statement. Letter C, does the S after the magnesium mean it's a salt? No, the S means it is a solid. Does MgO, magnesium oxide, have the same properties of magnesium and oxygen? Oh, no. That's false. Magnesium oxide has its own unique properties, very different than magnesium and oxygen. Magnesium is a metal. It can be rolled. It can be bent. It can be stretched. Magnesium is a metal. It's shiny. It's silvery. It can conduct heat. It can conduct electricity. Magnesium oxide does none of those. It is a salt. It is a white salt. Oxygen helps things burn. Does salt help things burn? No. Salt is not flammable. You have to heat salt to very, very high temperatures to get it to melt. It is not very reactive at all in that manner. So magnesium and oxygen have far different physical properties and chemical properties than magnesium oxide does. In fact, oxygen is a gas. Magnesium oxide is a solid. They have greatly different properties. Okay, let's come down here to our matching section. Number 15, what do we call the building blocks of matter? The smallest particle that has the properties and behaviors of an element. So what's the smallest particle of an element that has the behaviors and properties of those elements? It's also the smallest particle that can enter into chemical reactions. That is an atom, letter E. What do we call a pure substance that cannot be broken down further chemically? And it's made up of only one atom type. So this is really a collection of the same types of atoms characterized by having the same atomic number of protons. Well, a substance which cannot be broken down further chemically, it is the simplest type of substance we can have. That is the definition of an element. And it gives you here that there are 118 different elements that we know of. And each element has its own symbol to represent it. That's elements. Number 17, what do we call a blend of two or more different substances that are placed together? So we're placing them together. Nothing's happening chemically. It's not a chemical reaction. We're just putting things together. That's what a mixture is. A mixture is just things placed together where no chemical reactions happen. You can separate mixtures very easily physically. You don't need a chemical reaction to undo a mixture. What do we call a pure substance made up of two or more different elements chemically combined? It can be broken down further into the elements that make it up. So what do we call it, for instance, when two different elements join to form something? That's what we call a compound. A compound has properties very different than the elements that make it up. And it is represented by its own chemical formula that has two or more different symbols to represent it. That's what a compound is. Why do they call a compound pure? Pure in chemistry just means one thing. So if I only have one thing there, whether it's an element or a compound, it's pure. So if I have sodium chloride, table salt, and I dump it on the table, and the only thing there is sodium chloride, it's pure sodium chloride. If I pour water on the sodium chloride and that sodium chloride dissolves in the water, it's no longer pure. I now have two things there. Water that dissolved the salt, and now the salt that's in the water. That would be a mixture. Finally, what's the smallest example of anything that is joined that is able to go around together on its own? It can be the same atoms joining. It can be different atoms joining. It's generally a liquid or a gas. It's sometimes a solid. It can move around independently, and it's usually formed when things are sharing electrons. So what do we call it when things join and they're able to go around together? That's the definition of a molecule. That's the definition of a molecule. Number 20 through 26 are also definitions. What do we call anytime metals are melted and mixed together? It's not a chemical reaction. It's just the melting of different metals, such as brass, which is copper, and zinc. Bronze, which is copper, and tin melted together. What do we call that? That's an alloy. What do we call a homogeneous mixture all in the same phase? For an instance, a salt that is dissolved into water and it's all the same throughout. Salt water is an example of a solution. What shows the types and numbers of atoms of each element that have joined together really to form a molecule? That's called a molecular formula. The molecular formulas give you the number of atoms of each thing on a molecule. Water has 2 hydrogens joined on 1 oxygen. The molecular formula for water is H2O. What do we call the regular repeating pattern of ions held together by opposite charges? In other words, a positive, a negative, a positive and a negative, a positive and negative. A giant conglomerate of ions. That's called a crystal lattice, sometimes just salt crystal. In that crystal lattice are negative ions. What do we call the negative ion? That is called an anion. Remember, anion has an N for negative. Cation is the positive ion in a salt. The plus, the positive sign, the T in cation reminds you that that's the positive one. What do we call it when we form a solution? The thing that gets dissolved, in other words, the salt, if we're making salt water, is called the solute. The thing that does the dissolving is called the solvent. So when water dissolves the salt, water's the solvent. How well the salt dissolves is called solubility. How well the salt dissolved is called solubility. We're going to end this video right here, and we will proceed with another video for the remaining questions, or for the questions that we are about to follow these. So we'll stop this video at question number 26. Thanks for watching.